With their commanding presence at sea, today's cruise ships carry on a long and historic tradition. Long before jet planes, ships were the only way to travel the globe. Today, they carry thousands of people and have become a popular vacation choice. Competition is intense, with companies building ever bigger ships to drive costs down. But now in Italy, a team of craftsmen and engineers is taking on a new kind of shipbuilding challenge. They are racing to build the ultimate cruise ship, a superliner, finely crafted to the most minute detail.
I wanted to build something unique, one of a kind, never to be repeated again.
But building this record-breaking superliner involves a series of unique engineering challenges. The ocean can be a deadly place. How do you keep hundreds of passengers safe, sailing far from shore through violent storms and rough swells? And to complete the ship on schedule, the team must combine time-honored tradition with trailblazing technology.
To build a ship is a continuous pressure. We cannot miss our target.
Inside the extraordinary race to build the ultimate cruise ship. Right now on Nova. Today in Genoa, Italy, this team of construction workers is starting work building a brand new ship. One that will present a new and difficult set of challenges, both technical and aesthetic. For the team here is constructing a cruise ship they hope will set a new standard. In keeping with maritime tradition, a welder attaches rare coins to the hull to bring luck.
That's a beautiful thing.
And a priest provides a blessing. Engineers in this region of Italy have a formidable reputation. They have been building ships since medieval times. But this job will present new challenges beyond anything they've faced before. The worldwide cruise market has exploded over the past 25 years. From under 4 million passengers a year to over 22 million. It's a $39 billion a year industry. Competition is fierce, with companies building ever larger vessels to drive prices down and make cruising more affordable than ever.
Why don't we just do, like, you know, I'm doing a puzzle here.
But one cruise company and its CEO, Frank Del Rio,
Like that.
are taking this ship in another, more risky direction.
On deck 4, we need 4 pieces. My vision is very simple, to make this the most luxurious cruise ship ever built.
But is there a market for that? Where many of the big cruise ships hold over 5,000 passengers, this vessel, the Seven Seas Explorer, will carry just 750. But they will be paying top dollar, and their expectations will be equally high. They will be housed in 375 suites, and at the top will be a 4,400 square foot suite that will go for $10,000 a night. Are there enough people willing to spend enough money to keep this venture afloat?
There's risk anytime you break barriers, but these are calculated risks.
But this ambitious scheme is not just a business challenge. It's an engineering challenge for the ship's designers and builders. First, Luxury is heavy. The marble and glass materials needed to give the liner its sumptuous feel will add weight. Engineers need to invent clever ways to balance the ship so it remains stable in the water. And there's another, even bigger challenge. The ocean can be a deadly place. Without making it too obvious, engineers must devise ingenious ways to save passengers' lives in the event of a fire or a collision at sea. And there's a final challenge. The engineers must meet a tight deadline. To fill the ship with customers, tickets for the maiden voyage will go on sale before the liner is complete. Canceling them will be costly.
That would cost us in excess of $5 million to the immediate bottom line, and probably cost us $25 million in lost reputation. So an expensive proposition that we won't let happen.
In Italy, it's the job of engineer Pierluigi Punter to deliver the ship on time.
I am very proud to be in charge of this project. Several thousand people will be involved, but I will coordinate all the activities from the starting of the design up to delivery. I hope to survive.
The pressure is on Pierluigi and his team to turn these sheets of steel into a finished ship. To deliver the ship on time, Pierluigi has a detailed and ambitious plan. He will build his ship piece by piece in a dry dock, installing the engines and machinery as it goes. To save time, he must simultaneously construct a large section of the vessel in another shipyard, making sure it will join up perfectly to the rest of the ship. Then the shipyard will build up the decks to complete the hull, put in the cabins, fit the windows, and install the navigation equipment. To ensure it all works, they will test everything in a series of sea trials. And finally complete the interiors of the cabins and public areas. It's like building a floating city. And they only have 18 months to do it. Stage 1. The team needs to cut and weld together more than 12,000 tons of steel to assemble the liner's hull, the structure around which the rest of the ship will take shape. To build the hull in time, the team will employ an ingenious technique. In the past, ships were constructed from the bottom up, a bit like building a house. Only once the hull was finished did they install the ventilation, electrical cables, pipes, and machinery. But this method was slow. Too slow for today's competitive environment.
To build a ship is a continuous pressure. We have a penalty on the contract about the delay on delivery.
So to build the Explorer's hull, Pierluigi is using a technique developed in Japan in the 1950s, made possible by the invention of bigger, stronger cranes. Workers will first assemble the steel plates into sections 1 deck high, building them upside down to make it easy to install the pipes, cables, and ventilation as they go. Cranes will then flip the pieces over and join several together to form a megablock. It will take 53 megablocks to construct the Explorer. Once each block is complete, giant cranes will lift it into position. Using this mega block method, the team can work on many parts of the ship at the same time, speeding up production. The steel for each mega block begins life in a giant bath. Here, a computer-controlled plasma cutter cuts the steel to shape. The machine's nozzle fires a 30,000-degree Fahrenheit jet of superheated gas towards the steel at 20,000 feet per second. This melts and cuts the steel underwater, which keeps it cool and prevents distortion. But the next critical job must be completed by hand. 250 skilled welders join the pieces together to form each mega block. With welds as strong as the steel itself. It takes about 4 weeks to build each of the 53 mega blocks. This method of construction is fast, but not fast enough for the schedule. So Pierluigi has a plan to speed up construction.
We decided to build part of the ship in another shipyard to reduce the production lead time and to take advantage of the capacity of the two shipyards at the same time.
While the shipyard in Genoa is building most of the vessel, a large section has been assembled 400 miles away at a second yard in Castellammare di Stabia. This shipyard sits in the shadow of Mount Vesuvius. It has been building ships for hundreds of years. Over the last 8 months, the workers here have assembled 11 megablocks to form this 200-foot section of the ship. Now they face a daunting challenge. They must launch their section into the sea. A tug will then tow it up the coast to the shipyard in Genoa, where welders must attach it to their section of the vessel. If the plan works, it will cut 8 weeks off the construction schedule. Before they launch the section, surveyor Antonio Vairo must carry out one final check. For the last 8 months, he has been measuring the dimensions of this section.
We are measuring the length of the section to verify that it matches the plan's dimensions.
This section must be within 1/4 of an inch of the planned size, or it won't fit onto the rest of the ship.
It is essential because if what they've made in Genoa and what we've made here do not match, this will cause serious problems later.
The shipbuilders here are also concerned about launching this section of the liner, because sliding it down this slope into the sea is a risky maneuver. In 1907, another Italian shipyard proudly launched its new ship, the SS Principessa Yolanda. She slid smoothly into the sea and then promptly capsized. The shipyard had somehow neglected to install any stabilizing weight in the bottom of the hull to lower her center of gravity. To prevent their section from capsizing, the workers here have built it with a heavy, double-bottomed hull and installed water and fuel tanks low down to ensure that the vessel will be completely stable when launched. Workers cover the slipway with a thin coating of wax. Then a layer of grease to make sure that the section of ship doesn't get stuck. The stage is all set for the next day's launch. "8 a.m., 3 hours to launch. A team of workers starts driving wedges under the keel. The aim is to lift the ship just enough to free it from its supporting pillars so it can slide into the water.
The scope of hammering the wedges is to transfer the ship weight on the central sledges. In this way, it will be much easier for us to remove the side pillars. They will lift the ship for less than 1 inch. It's 10:20. We are going to remove the last 2 pillars, and so we are almost ready to go.
Half an hour before launch, workers remove the wooden props supporting the hull. The last things holding the ship are 6 steel claws that will be released by hydraulics. When the string is cut to smash the bottle, this weight will also drop, opening a valve that will release hydraulic fluid, retract the claws, and launch the section of the ship.
La nostra opera è su tutti noi, scena la benedizione di Dio Onnipotente, Padre, Figlio.
Following ancient tradition, a godmother launches every vessel to bring it luck.
Marina, in nome di Dio, taglia!
There's no engine or rudder on board this section of the ship. So the team is counting on 165 tons of chains to slow it down and stop it from plowing across the harbor and smashing into nearby boats. The weight low down in the hull keeps the section upright.
It was a very positive day. We have the weather on our side. Now we have a sunny day, so everything was good.
Tugs must now haul this empty section of hull around the coast to Genoa. If all goes well, it should take about 4 days to cover the 400-mile distance. The challenge of figuring out how to propel the Seven Seas Explorer when it's completed lies with marine engineer Gianpiero Lavini.
One of the main targets is to get a very, very comfortable vessel, completely silent and free from any kind of vibration.
The vibration must be low enough to qualify the vessel for a standard known as comfort class. To power the Seven Seas Explorer through the water, 4 massive 8-cylinder diesel engines will drive 4 generators. These will supply electricity to two 9-megawatt electric motors that will turn two huge propellers, pushing the ship forward at over 20 knots. The design of the ship's propellers is critical. If Gianpiero's team gets it wrong, the ship could vibrate violently.
When you are at sea, if you have any type of troubles, you cannot take any action because you cannot modify the propeller. It's absolutely impossible. So you'd have to know everything in advance.
In 1907, during the sea trials of the Lusitania, at that time the world's biggest ship, the vibration was so bad, they had to strengthen the interior in a failed attempt to stop it. When they investigated, they discovered that the problem came from the ship's propellers. When a propeller rotates, it can create areas of very low pressure on the back of the blades, causing water to form bubbles of water vapor in a process called cavitation. When the bubbles burst, they collapse in microseconds, sending powerful shock waves through the water onto the ship's hull. This creates uncomfortable vibrations for people and objects on board.
Cavitation is the worst enemy of a propeller designer because it is the main source of noise and vibration. So I'm not satisfied till I have removed every bubble.
To keep the Seven Seas Explorer from vibrating, Gianpiero must minimize the cavitation on the propeller blades. The simplest way to do this is by slowing the propellers down. This reduces the area of low pressure that causes bubbles. But this would also slow down the ship. So to compensate, they will make the propellers larger and add more blades. These larger, slower spinning propellers will exert the same power, but should drive the Explorer through the water without vibration. The ship's propellers are being cast from bronze at this factory in the Netherlands. The task requires extreme precision. If workers here don't reproduce Gianpiero's design to a fraction of an inch, the propellers could still generate vibrations. They feed his plans into a computer that will carve a mold in sand bonded with resin.
We are able to accurately create a shape by a grinding of the sand mold, and all the material that's not needed is cut away so that we get a precise shape that we want it to be.
From the resin-bound sand, the machine must first carve the base of the mold, then make 6 blade-shaped pieces to form the top, leaving a propeller-shaped gap. Workers will place this mold in a steel frame, add a system of tubes to pour in the molten metal, then cover it with sand to prevent the top of the mold floating when they fill it. The foundry will cast the propeller from a special bronze alloy, a mixture of copper, nickel, and aluminum.
The alloy that we use is actually called nickel aluminium bronze, and it's very corrosion resistant, and it's a strong material, so it's quite suited for ships' propellers.
But the size of the special propeller creates problems.
It's a big propeller. It weighs, when casted, about 30 tons.
To avoid serious imperfections, they must fill the mold in one continuous pouring. But this propeller needs more bronze than their largest ladle will hold.
What's special for this project is that we use 2 ladles at the same time to make sure that the mold is filled at once.
Using 2 ladles speeds up the pouring process, helping ensure that when the mold is broken open, the propeller will contain no serious imperfections. Once they start pouring, there's no going back. It takes less than 3 minutes to cast the propeller, but it will take 3 weeks for it to cool and harden. Only then will they know if the propellers will be ready for their installation in 4 months. But right now at the shipyard in Genoa, workers are anxiously awaiting the hull section from Castellammare.
Today is an important day. We are going to join the 2 big sections. As soon as the section coming from Castellammare is arrived, we close the gate of the dry dock and we start to empty the dry dock.
Pierluigi won't rest easy until he knows that the 2 sections are perfectly joined.
We don't have the plan B because only the A can exist.
But bringing them together in this narrow dock will be a challenge. The dock's width restricts the size of tug they can use to pull the section in. And gusts of wind blowing on the vessel's large surface exert a powerful force, making it difficult to control. The tugs struggle to wrangle the flailing 3,300-ton section of ship through the tight entrance. Once they've placed the section safely in the dock, the workers close the gate. Now they must align the 2 sections precisely to make sure the ship is straight before they're welded together. The first stage is to start the pumps to lower the water in the dock. As the water drains, they will first winch the smaller section into position. It sits 3 feet lower in the water than the newly arrived section because it contains the ship's heavy engines. As the hull drops, divers will guide its marker pegs into sockets fixed to the dock floor. Once it is firmly in position, the team will winch in the section from Castellammare, line up its marker pegs, and let the draining water lower it precisely into place, ensuring that both sections are perfectly in line. Lowering the first section into position is the easy part. Lining up the new section from Castellammare will be more difficult. 4 diesel-powered winches enable them to maneuver it with precision. Steel guides lead it into its approximate position. But guiding the marker pegs into place underwater needs an expert eye. A diver will help the team line it up precisely.
Matteo, quanto manca all'imbocco della forchetta? Ok, più o meno 65.
They restart the pumps to lower the second hull. This will be the moment of truth. Will the 2 sections fit?
Ok, piano piano sta andando, va bene.
The diver shows them they are out of alignment.
Come prima, 2 centimetri. Siamo perfetti.
After some maneuvering, the alignment is looking better.
Now it's in place.
It fits. Both sections of the hull line up precisely. Once they are welded together to form a single vessel, it will be time to install the propulsion system. In the Netherlands, the propeller has cooled and been released from its mold. Now workers must grind its blades to their precise shape.
They have different tools to grind away the material. They start with the coarse grinder, and afterwards they will get to the finer grinders.
These grinders are equipped with tough aluminum oxide cutting heads that shave off a thin layer of bronze on each pass.
Well, there are marks on the propeller blade on how much material needs to be removed. It's a few millimeters.
Over a period of 4 weeks, the grinders will remove about 1 ton of bronze from the propeller. It's highly skilled work. Any unwanted bumps left on its surface could cause the ship to vibrate. And if they damage it, making a replacement from scratch will take months and delay the maiden voyage. While work continues on all stages of the ship's construction, across the Atlantic Ocean in Coral Gables, Florida, another team is rushing to design the fittings for the liner's high-end cabins and common spaces. Johandel Ruiz faces his own challenge. Luxury items like stone floors and marble walls are heavy.
Weight is one of the biggest concerns we have on board a ship, so you try to put the majority of your weight in the lower decks. If you're doing stone floors, you will limit the amount that you will use on the upper decks, just to prevent the ship from listing. So as you go higher on the ship, you tend to use lighter, more airy materials.
But Johandel will have his work cut out for him. The most expensive suites on the vessel, full of stone and marble, will sit right at the top of the ship. They must make sure they don't jeopardize its stability. If they put too much weight high up, it could lead to disaster. In the summer of 1915, the SS Eastland, with 2,500 passengers on board, was about to set off for a pleasure cruise on the Chicago River. After the Titanic disaster 3 years earlier, government legislation had required the ship's owners to install more lifeboats on the main deck. Unfortunately, the extra weight of the boats made the Eastland top-heavy and unstable. Before leaving the harbor, it rolled over and capsized. 844 passengers and crew died. At the shipbuilder's headquarters in Trieste, Michele Moro must keep a detailed inventory of the weight of every object on board the Explorer and where it sits on the ship.
We have inside about 20,000 items recorded.
From lifeboats to bathtubs, pianos to plates.
This is the description of the item. This is the position of the deck. We have the quantity. This is the kilos.
A computer plots the location of every object to calculate the stability of the ship. To position the most expensive and heaviest suites high on the ship, Michele has figured out they must cut tons of weight from elsewhere. Instead of the original vision of glass balconies, designers must use lighter steel railings. The ship's funnel or chimney will no longer be steel, but an aluminum alloy, which weighs half as much. But that's still not enough. Johandel needs to find a way to slim down the furnishings.
What we decided to do, you use a honeycomb system similar to what I'm holding here. So half of the panel would be a marble or a granite, and then it'll be back to a honeycomb made out of aluminum, and it'll keep it very light and airy. As you can imagine, 52 suites times a lot of marble equals a lot of weight. So making small changes, including this, we've been able to reduce the weight quite significantly.
With the calculations complete, over 1,000 workers in Genoa are now racing the clock to finish the ship. In the space of 4.5 months, cranes winched the megablocks forming the upper decks and the aluminum funnel into position. 42 megablocks are in place, leaving only 11 to install. It's beginning to look like a ship. To deliver the vessel in time, 8 months from now, work on the ship reaches a fever pitch. Inside, the steel labyrinth of the hull pulses with industry. Teams of electricians, fitters, and mechanics cram nearly every space. Power supplies fill the dockside. More than 40 miles of cables feed electricity to the welders on board. Underneath the ship's hull, engineers are gearing up to fit the starboard propeller, the second of two.
We've prepared the propeller shaft to receive the propeller, and now we will lift the propeller using the pulleys and start installing it on the shaft.
The team must thread the 14-ton propeller onto this 120-foot-long shaft. The propeller must sit absolutely symmetrically on the shaft. If it's off-center, when it turns, it will cause the ship to vibrate.
The machining requires such a high degree of precision that we don't talk about millimeters, but tenths or hundredths of a millimeter.
The smallest impact between the propeller and the shaft could damage both precision-crafted components.
The final stage is without doubt the most critical. If the propeller gets damaged during installation, it will be a major problem because it will take several months to supply a new propeller.
It takes 8 hours of painstaking work to mount the starboard propeller.
Coupling of the propeller with the shaft is complete. It all went well. Just a few more activities and the ship will be ready for launch.
It has taken 1,500 workers 9 months to assemble the megablocks, install the electrical and ventilation systems, and fit 2 massive propellers. Still, inside, there's a huge amount of work to be done. Large areas of the Seven Seas Explorer are bare steel. The shipyard team has just 7 months to transform this cold gray skeleton into a floating palace. At workshops in northern Italy, teams of craftsmen are busy manufacturing the wall coverings and furniture. But some luxury materials present hazards. One of their greatest concerns is fire. In April 1990, an arsonist started a fire on board the ferry Scandinavian Star. The fire spread rapidly. Poisonous smoke spread through corridors and into cabins. 159 people died. To prevent a similar disaster today, the ship is divided into compartments. If a fire breaks out in one, doors automatically close to contain the blaze. These doors do double duty. In the event of a collision, they also prevent water from flooding through the ship, keeping it from sinking. But there's one thing the doors can't stop: If a fire destroys the control cables running from the bridge to the engine room, it could cripple the ship. On the bridge, technicians are wiring up the Explorer's controls, connecting them to the propulsion system and to the GPS-enabled automated navigation system, which is accurate to 6 feet. Because these wires are so critical, the ship is being built to a new 2010 safety standard called Safe Return to Port. Unlike older cruise ships, every control and power cable on the Explorer will have a backup, routed through a different part of the vessel. So if one network is burned out, the ship can still sail safely on to the nearest port. If a fire destroys the main bridge, the Explorer has another line of defense. A backup bridge, 4 decks higher up.
This is an emergency wheelhouse, and it's closed in a protected box. So in case of a fire, of real emergency, you can maneuver the ship from here. The cables that are coming here are completely separated to the rest of the cable on the ship.
The maiden voyage is just 4 months away. But with so many details to attend to, the work is falling behind schedule.
This is a luxury ship, and we need to take care of all the small details of the installation. This is the most challenging part of the building.
To get the vessel ready on time, Pierluigi pulls out all the stops.
We have a lot of people on board. Today there will be about 1,500 people.
Workers are under intense pressure as they lay over 500,000 square feet of flooring and install over 1,800 panes of glass. And there's still one final hurdle to clear. Before the shipyard can deliver the vessel, the ship must pass a barrage of tests called a sea trial. The pressure to get underway is now really on. Three weeks later than originally planned, over 500 engineers and technicians board the ship for the sea trials. The Explorers set sail for the first time.
Solo 10.
Okay, see you.
It's make or break for Pierluigi. Over the next 3 days, his team will run tests on every critical system on board. And the builders have to be on hand to answer questions. The person who will make the final decision is ship surveyor Jean-Jacques Genet. Jean-Jacques and his team must certify that the ship conforms to international regulations and is seaworthy.
But it's completely independent from what we have on the bridge?
One gyro is here.
Okay.
And one GPS is here.
At the end of the building period, we will issue class certificates which will allow the ship to sail, and we will also issue safety certificates. And this will allow the vessel to take passengers. Without these certificates, the ship is just a floating piece of steel.
They will run the tests around the clock. One of the first is on the anchor. If the ship loses power, to stop it drifting, they must be able to drop the anchor fast.
it goes perfectly.
They test the steering system to check how fast the ship can turn if it runs into danger. But for a cruise ship, there is another test that is just as critical. For the ship to be comfortable, it must sail with almost no vibrations. Has all the work designing and making the special six-bladed propeller paid off?
For the owner, this will be an important test because this will measure the level of comfort that passengers will feel during their cruises. So we are a little bit nervous also because these parameters are really important for the owner.
Technicians must visit every part of the ship and measure the vibration. The test must be carried out under the most demanding conditions, when the ship is sailing at full speed. This vibration sensor measures any movement of the deck. It needs weight to hold it firmly in position. As the ship sails through the night, they collect their readings. In order for the ship to qualify as a comfort class vessel, the outcome of this test is critical, as is the overall result. After 3 days and nights, Jean-Jacques Junet gives the verdict.
The measurements have been done here during this sea trial. They are quite impressive, impressively good. Yeah.
The Explorer passes all its tests and is certified to sail. But Pierre Luigi and his team can't rest on their laurels.
The result was very, very good. Now we have the final rush.
In the final few weeks, the activity on board becomes frantic. Hundreds of craftsmen are racing the clock, installing over an acre of marble and 473 chandeliers. This is intricate, time-consuming work. Two days before the ship must leave the shipyard, CEO Frank Del Rio arrives from Miami and finds the work is far from complete.
I was worried at the time I signed the contract 3 years ago, so yes, I'm worried. But we're working through the night, we're working double shifts.
They are cutting it very close. The night before departure, the theater isn't finished, and the band is on stage rehearsing the first show. But the next morning, there's an amazing transformation. In the nick of time, the ship is passenger ready. On the bridge, her first captain, Stanislas Mercier de la Combe, takes command.
2, 3, 5.
He sets course for Monaco, where the ship will be christened. After 20 years at sea, he experiences for the first time a brand new ship under his control.
For 10. The ship is amazing. We are able to go nearly at 21 knots, and there is basically no wake. The maneuverability of the ship is really nice, a lot of power, but we just start to know each other. So it's a bit like a first date. We take things very slow, very gentle. Hard to port.
Safely docked in Monaco, they make final preparations to receive the first passengers.
One New York strip medium, one porterhouse medium.
In the galleys, the ship's 85 chefs start preparing the haute cuisine meals. In the $10,000 a night Regent suite, the butler sets the finishing touches. All is ready for the christening ceremony. The ship's godmother, Princess Charlene of Monaco, will christen the ship with a Goliath bottle containing 7 gallons of champagne.
I bless the ship, Seven Sea Explorer. May God bless her and all who sail on her.
Station 1 and 2, we are underway.
Okay.
After 3 years of design, 18 months of construction, and the work of thousands of engineers, designers, and craftsmen, the Seven Seas Explorer is finally ready to sail the oceans of the world.
This NOVA program is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. NOVA is also available for download on iTunes.